that's annoying. Where could you have found what you needed for section 10.2? You guys see some stuff like a diagram that we had in our notes or like some formulas that we had in our notes, right? Now, was the book quite as nice at writing out like the focus and the directrix and how it's P away and all that sort of stuff? It was a little iffy, yeah? Now, well, hold on. Did they have, though, at the bottom this huge conglomeration of all the different possible orientations of a parabola, all the different possible ways that the focus could go, what the points would look of the focus if you use the P correctly, and the formulas for the directrix as a result? Whew. You could have put this in your notes, but here's my question. Can I just see by a raise of hands, did anybody go back to this and use it at all at any point during homework? 1, 2, that's it? Interesting. Okay. If this was helpful in any way, shape, or form, and some of you were like, I didn't know it was there. Well, hold on. It actually was in your notes also. I just said you can take a picture or you can reference it, because it can be quite helpful. I totally agree. There it is. I just kind of put it together in one big page. If you guys were like, oh, that might have been nice, if the visual thing didn't totally get you there in each of the examples, you might want to now take a picture of these 4. And maybe either copy them into your notes or just refer to it later. There are ways of having formulas to plug into for a particular problem. Now, I still think in some way, shape, or form, depending on the clues that they give you, it's still helpful to sketch. It's still helpful to draw to figure out which camp or which version or which variation you should go to. However, if some of your brains are like, you know, I tried that whole visual thing, it made sense in class, and when I got to homework, I couldn't do it, I think you might need this page. But what's the dilemma with me telling you you might need this page? You have to memorize it. Now, maybe if you use this page over and over again, maybe the visual thing will come and how it works will come. But yeah. Just kind of like a warning for you guys. If this page is really helpful, maybe you'll get the hang of it in a way that you won't have to keep on using it. But you can start using this page, and if worse comes to worse, make a study sheet for each section 10.2, 10.3, 10.4, 10.1 with the formulas, the pictures, etc. to be studying. Now, there was one other place that I fully expected you guys to get stuck on, which is why I made a point of showing you and even highlighting it yesterday. Could you have gotten stuck at in some way, shape, or form, at some point in homework with a number being there and forgetting that 4p was what it needed to be set equal to? Because -8 was not the p. You needed to divide the -8 by 4 to get -2 in order to actually get that distance, to get to the focus, to get to the directrix, etc. So I think the other place that got tricky, besides just getting a standard form equation and plugging in appropriately to get the focus, the directrix, the vertex, was the coefficient equals 4p, not just p itself. Then last but not least, all that completing the square stuff that we went through yesterday. Those were the 3 places I expected you to get stuck. Well, there was that whole tangent line thing, but let's see how you guys did. Okay? So with the evens. Oh, sorry, wrong document. Choop, choop, there he is. With the evens, let's see how we did. We have number 10, number 12 matching with B and F, and then number 14 matching with C. We have number 10, number 12 matching with B and F, number 14 matching with C. I think I gave you guys probably the odds too in that section, right? But hopefully you already checked those odds. But let me give you a little bit of time with number 36, because number 36, I think, was the first where you were supposed to take an equation and start identifying stuff. True? So let me give you a second. Was this equation meant to be in a really hard form, though? Was it meant to be in a really hard form? No. All you had to do, did you guys see it, was subtract this to the other side. So then you would have your y minus k squared equals -1 x minus h squared. Now, they write it in a weird way. They took that -1 off to the side, and they said -1 has to equal 4p, p has to equal -1/4. So they wrote the -1 in a weird way, but it would have been the exact same thing as if you had done that whole p thing. So let me just show you that really quickly. I think that might help some of you. I know it's cold. The air just turned on. It was super hot all morning. I need my remote. Just kidding. Okay. Just in case it helps. I wouldn't have written that. I would have written, because we would have just subtracted that lump over there, and then I would have thought, oh hey, this needs to match up with, I would have compared it to my standard form, just like we did yesterday. And I would have said, oh, 4p has to equal -1, p has to equal -1/4. Ha-ha! And then I would have gotten my vertex of, well, you guys can see it down there, but x minus h, so a -5, y minus k, so a 1. And I would have graphed. Now, the problem is they use like a computer program or a computer grapher to graph this, and so it's super shine. And I put them down too, that doesn't help. We'll try. Okay, so now that I have new batteries. With an ellipse, I can't just go one distance because one distance, doesn't it change for an ellipse if it's a little bit squished? It's not just one distance because well, that's not a perfect circle up there, but an ellipse will still have a center, which is going to be the midpoint of both of the axes, the horizontal and the vertical axis, through the ellipse. So it still will have a center, but an ellipse is not equidistant from the center. Sometimes it's shorter, sometimes it's longer. And we give names to that shorter and to that longer. And then, well, we go with the longest it can be, we go with the shortest it can be. We give those two names, and everything else is just kind of in between. We don't really give names to those. So an ellipse isn't going to have one radius. That's going to be a little bit different. But instead of talking about one radius, we're going to actually be talking about this guy, which we're going to call the major axis, this guy, which we're going to call the minor, and not even just the major axis is horizontal for this one, minor axis is vertical, major is the longer one. Minor is the shorter one. Major is always going to go with A, minor is always going to go with B, so it kind of depends on whether it's longer vertically or longer horizontally as to who's the A and who's the B. But the A is only half that distance, and so actually we call the A the major radius and the B the major, or the minor radius, and then we call the whole thing the axis. But we're kind of getting into, I don't know, I think the formulas. So let's go ahead, and that's the visualization. I'll show you guys tomorrow. Let's get to the yellow box. Let's get to the yellow box. Let me give you just a second to set up the yellow box. And if you notice, I'm going to start kind of color coding a few things to help out. I can use purple, I guess, for A. A in this one goes with the X, which means I have a major horizontal. I'm going to take away, though, the circle from the X. That's kind of nasty. The A is going to be the major radius. And then the B is going to be the minor. But if you notice in this one, the horizontal or the x-axis got the major and the vertical or the y-axis got the minor, but right down here it switches, doesn't it? Right down here, the minor is going to be the x because he's the shorter dude. And the y is going to get the major because he's the longer dude. So it totally just kind of depends on what's what. And the nice thing is we eventually are just working with numbers, and the A's and B's don't matter as much. But for those of you that memorize with letters, it gets a little confusing because A just follows the highest guy with ellipses. So I'm going to write that off to the side just in case it helps. So wherever B is, he's going to be the minor radius. And wherever A is, he's going to be the major radius. Half the distance, or the distance from the center to the outermost.
So A is always the major?
Yeah. A is the major. Whether it's horizontal or vertical, A is the major. B is the minor, whether he's vertical or horizontal. B is the little guy, A is the bigger guy. And if you notice, there are these other points, though, called vertices, but they're only on the edge, on the outer edges of one of the axes. So off to the side, I'm going to say the vertices. The center for each of these, the center is always going to be HK. So the center is HK for both, which is nice because it's just like a circle, just like even a parabola. HK is the center. But we still actually have vertices for ellipses, but they're along the major axis, and so kind of like the foci and the directrices for the parabolas and how they switched as to whether we were adding and subtracting from the y to the x's. if the major is horizontal, then we're going to extend horizontally to our vertices. And so we're going to take the H, add and subtract A, and keep the K. Maybe now you guys also know why I accidentally wrote plus A or minus A on the page before. But if the vertices, well, I should say if the major axis is vertical, well then the H is going to stay the same and the K is going to add or subtract the A. It is, but then again it's not. Vertices are kind of like the central point of a parabola, right? And if you, well, because if you think about two, now, is an ellipse truly two parabolas coming together? No, because it would be pointed. But the idea of a vertex being the coming together of a curve, I can still use that to describe an ellipse, but I only need it to be defined on or along one axis, because the other one will just kind of naturally happen as a result. I don't need vertices everywhere. So now they aren't true parabolas, but as the curvature of the ellipse extends from the two vertices, they will meet and form my ellipse. If that makes sense. That's why I only need two. And I need two because one wouldn't be enough, because one would just keep on going forever. It needs to somehow be bounded by another one in order to be an ellipse. Now, we don't just have vertices though. Guess what? We also have, you see a second ago, there are foci. Foci? What? And a parabola only had a focus. Oh yeah, but ellipses have two. We'll do the visualization tomorrow, but two focuses. I don't know exactly where this one goes without doing the math and knowing the measurements. But I know approximately it's at least pretty far away because these ellipses are pretty flat. I'm going to have two foci. So coming out from the center, I have two vertices, and coming out from the center, I have two foci. The foci are going to act just like the vertices in that they're going to be along the major axis. So it's H plus or minus, but not A, and not B. It's going to be a C. You're like, what? Don't worry, it's coming. Who is C? C squared equals A squared minus B squared. And technically, I kind of tried to squish it all in one yellow box for you guys. But to make it a little bit more detailed, like to take away all the extra major and minor and center and vertices, we could just focus in and say, okay, so from a center, I'm going to go C units away to get to my focus, one direction and the other direction. And so that's where these little formulas come from if I have a horizontally oriented one. Or if I had a vertically oriented one, I would go C up to get to my focus and C down to get to my focus. So isn't C kind of like the old P? P is for parabolas. That kind of is a nice way of remembering it. Before P is for parabolas. For all the rest of the conics, C is going to be our distance to our foci. And there's always going to be some sort of special formula, like this one right here. Doesn't it kind of look like Pythagorean theorem? C squared equals A squared plus B squared? Close. Close. It's not quite. It's a little bit different. But the focus needs to be within the ellipse. Because if you think about it, isn't the focus always within? It's just a way of remembering. Isn't the focus always within the curvature? The vertex is the boundary of the curvature, like a parabola. The focus is within. Same thing with an ellipse. The focus is within. But we don't go from the vertex. The focus is within. Because our center is way easier to find. So we use our center for an ellipse. Mathematically, it's way easier to find. We use our center to get to our foci, to get to our vertices. It's a little different how we do things. But if you guys notice, we still have like these standard forms we're going to try and get them into. We still have these formulas or these clues, and they're actually ways of kind of visualizing, like with parabolas, to get from or with certain clues to the extra pieces that we're trying to find. So all of that brings us up to an example. All that brings us up to an example. But if you guys want, it might not be a bad idea to take a quick picture if you haven't gotten any of the information. And to be honest, that page really could be summarized on this page. Like, this page is the most important one. So I'm just going to add at the bottom really quickly. C squared equals A squared minus B squared. You want it just in one big old place. And that's for our foci. And then I'll zoom in so that you guys can see it a little bit better before you take your picture, because that other one would have been pretty fuzzy and pretty weird. All right, you guys got it? I don't have a lot of time, but if we can get one example, that would be, not that page. That could be helpful. What are they asking you to do? Find the standard form. Okay. Look at the picture. Which standard form? It's always helpful to have a standard form to begin with. Which standard form are we going to use? Who's major? Yeah, the x is major, right? Because it's longer than it is tall. So x minus h squared all over a squared equals, no, sorry, plus. Who's my center?
0, 0. Yeah.
Because if you think about the midpoint, was it 0, 0 in the middle of all of these? Yeah. So I can just plug in 0. Well, that's just x squared, right? And then y squared, because 0 just leaves x and leaves y. Who's my A? The longer half distance. Well, guys, how far from center to the edge? 2. So this is going to be 2 squared, or ultimately 4. That's my major radius. What's my minor?
0.3.
3 halves, or 1.5. So I could put 3 halves. Now, do you think they'll leave it like that? Some will be like, please, 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 no. We could do x squared over 4 plus y squared over, give me 1 sec. But do you think they're going to leave that as a complex fraction? So all they're going to do is division of a fraction is multiplication of its... We'll see more on Monday. But yeah, you have the basics. You have the basics. Division of 9/4 is multiplication of 4/9. You could go further and multiply both sides by 36 and get rid of fractions, but that's a nice standard form to me. Bye, guys.